talk about solving polynomial equations by factoring. You should have done the evens, or at least most of the evens already. If you haven't, there's some of them I'm going to pick up towards the end, so you should be fine. So you should use your graphic organizer to help you kind of guide your steps as you go through this. The first thing that we want to look for anytime we're factoring is that it's set equal to 0. This one is. Since it is, we're going to look at a GCF. So this one has a GCF of x, so I'm going to put an x out front, open a parenthesis. I'm going to divide each of these by x, which means I'm subtracting the exponents. So this would be x squared plus 1 equals 0. X can't factor any further, and neither can this x squared plus 1 because it has a plus 1 there. So then I'm going to set each of these equal to 0. So x equals 0, and that one's done. And x squared plus 1 equals 0. I do need to solve this for x, so I'm going to subtract 1 first, which gives me x squared is equal to negative 1. And then to undo squaring, I'm going to square root. Since I'm square rooting a negative, it means I'll have an I in my answer. 1 is one of our perfect squares, and the square root of 1 is just 1, so this will be plus or minus I. And you can write 1i if you want, but you don't have to. So those are our answers. X equals 0, x equals positive and negative I. Okay. Moving on to our next one. Our next one says x to the 4th minus 64 equals 0. It's already set equal to 0, so we're good to go there. This one is difference of squares, so it is subtraction, and both of these are perfect squares. So since they're both perfect squares, I'm going to square root each one. So I'm going to have x squared plus 8 and x squared minus 8 equals 0. Okay, so that x to the 4th is getting cut in half, but that 64 is getting square rooted. Okay, and one's positive, one's negative because it's difference of squares. X squared plus 8 can't factor any further, so I'm just going to set it equal to 0 and solve. And x squared, that's a squared. X squared minus 8 can't factor any further because 8 is not a perfect square. So I'm also going to set it equal to 0 and solve. On this side, I'm going to subtract 8 from both sides so that I get x squared is equal to negative 8. Then I'm going to square root that negative 8. Okay, so it is negative, so we will have an I in our answer. But we want to look for the largest perfect square that goes into 8. So the largest perfect square that goes into 8 is 4. That's 4 times 2. So this is going to be x equals positive and negative. We're taking the square root of that 4, which is 2. So 2i square roots of 2. Okay. Then we're going to do the same thing with the other side. I'm going to add 8 so that I get x squared is equal to 8. I'm going to square root both sides. And then I'm going to find the largest perfect square that goes into 8, which would be 4, which is 4 times 2. Since 4 is our perfect square, that's the one we're going to take the square root of. The square root of 4 is 2. This one does not have an I in it because it was not negative. Okay. All right, so we're going to keep going. Okay, we have x cubed plus 125 equals 0. Notice this one is already set up equal to 0, so we're good there. We want to look through our two terms, and if you notice, this one would be the sum of cubes. I am adding, this is a perfect cube, and this is a perfect cube. So I'm going to take the cube root of each of those. Okay, so this will be x plus, and then the cube root of 125 is 5. Okay, and then I'm going to follow my formula. So I'm going to write my formula up here. It's, I don't know if I wrote it with x's or y's or a's and b's for yours. I'll just do it with a's and b's here. It's a plus b, and this formula is on your graphic organizer from before spring break. A squared minus ab plus b squared. Okay, so that's that formula that you should have. So we have x plus 5. This is our a and b. So we're going to fill in the rest of this by using that. And so I'm going to say this is x squared minus, I'm going to multiply x times 5, which would just be 5x, plus, and then I'm going to do 5 times 5, which is 25. Okay. And then I'm going to set each of these equal to 0. So I'm going to have x plus 5 equals 0, which just means x equals negative 5, because you're subtracting 5 from both sides. Okay. Now this other one, I can either use any of the methods that we used in our previous unit, and so I could use like completing the square, quadratic formula. I can't use factoring because this one doesn't factor nicely. So I'm just going to use quadratic formula. If you've forgotten what that is, it's x equals negative b plus and minus the square root of b squared minus 4ac all over 2a. So basically what I'm going to do is I'm going to fill in this formula and then just simplify. So our a is the number that's in front of x squared, b is the middle number, and c is the last number. So I'm going to say x equals negative of negative 5 plus and minus the square root of negative 5 squared minus 4 times 1 times 25 all over 2 times 1. And when I simplify this, I'm going to simplify it in stages. There are some page protectors on my desk behind the yellow and red folder that you can use to help fill this formula in. If you want to use like an Expo marker or something to help with that, you can. Goodness. Okay, so we're just going to do this in small stages. So negative of negative 5 is 5. Plus and minus the square root. And then I'm going to put that stuff in my calculator. So that's going to be negative 5 squared minus 4 times 1 times 25 is going to be negative 75 all over 2. There's a negative here, so that lets me know my answer is going to have an I in it. But I'm looking at the 75. 75 is not a perfect square, so I need to find the largest perfect square that goes into 75. So you can look at your list of perfect squares that we've made, but it should be 25 and 3. 25 is our perfect square, so I'm going to say x is equal to 5 plus and minus the square root of that 25, which is 5i, square root of 3 all over 2. Okay. The 5, and the 2 don't have anything in common, so I can stop right there. Alright, like I said, you can pause at any time if y'all need to take a minute to write some stuff down. We're looking at number 7 now. Number 7 says x cubed minus 216 is equal to 0. Good news is that it's already set equal to 0. So we're just going to go, if you look on your chart, this one looks like difference of cubes. So we're just going to use the formula that says difference of cubes. I'm going to start by taking the cube root of each of these. So this would be x minus, and then the cube root of 216 is 6. Sixes are not pretty on here. Okay, if you're not sure how to find that cube root, you can make a list of perfect cubes the same way that we made a list of perfect squares. Also in your calculator, you can hit math and then find the one that says like cube root. It has a little 3 with a square root and put 216 in there. Okay, so then for our formula, we're going to fill this in. We're squaring the first one, so that's x squared, plus, we're going to multiply them together, x times 6, so 6x, and then square the last one. 6 times 6 is 36. And on this one, they're all positive. Okay, then I'm going to set these equal to 0, so x minus 6 equals 0. I get x is equal to positive 6. And then I'm going to use quadratic formula for this one again. X equals negative 6 plus and minus the square root of 6 squared minus 4 times 1 times 36 all over 2 times 1. So x equals negative 6 plus and minus the square root of, right, so in my calculator I'm typing in 6 squared minus 4 times 1 times 36, and I get negative 108. Okay, so negative 108 is not a perfect square, so I do need to see the largest perfect square that goes into 108, which is going to be 36 and 3. Okay, so that means this is going to be x equals negative 6 plus and minus the square root of 36, which is 6i, square root of 3 all over 2. Okay, this time when I'm looking at this, I have negative 6, a positive 6, and a positive 2. I can divide all of those by 2, so I'm going to. This will be negative 3 plus and minus 3i square roots of 3. And you can put it all over 1 if you want to, but dividing by 1 does not change anything, so I don't have to write it. All right, we're looking at number 9 now. Number 9 says x to the 4th plus x squared minus 42 is equal to 0. Okay, this one's what we call like a quadratic form. Um, so we're going to look at this the same way we would if it just said x squared plus x minus 42. I'm going to look at the factors of negative 42 that add up to 1. There's a baby crying in the background. Okay, so this would be 1 and 42, 2 and 21. And remember, if you know from your chart, this goes positive, negative, which is telling us that the bigger number is positive and the smaller one is negative. So negative 3 and 14. And you can just go to it if you know what it is. Negative 6 and 7. Okay, so these two add up to 1. That's right here. Okay, so I'm going to rewrite this as x squared minus 6 and x squared plus 7. Okay, because this one looks like a quadratic, it just has x to the 4th instead of x squared. Instead of writing it as x minus 6 and x plus 7, we write it as x squared minus 6 and x squared plus 7. So then I can set these. This would be x squared is equal to 6, and x squared is equal to -7. I do need to simplify these further by taking the square root of each of these. So this would be x is equal to positive and negative square root of 6. Now 6 is not a perfect square, and there are no perfect squares that go into it evenly besides 1, so I'm done. And then on this one, this would be x is equal to positive and negative square root of -7. Again, 7 is not a perfect square, and there's no other perfect squares that go into it. The only thing we need to deal with is the fact that there's a negative there. Since there's a negative, I'm going to rewrite this as x is equal to positive and negative I square roots of 7. And that would be my answer. Okay. All right, so it looked like for the most part we got the evens up to number 10 if you watch that first video. If you don't, I can get that video for you. But we'll do all of these from here on out so that you can see them. And hopefully it helps. And then you'll have some time either today or tomorrow to work on the assignment that goes with this. Okay? X cubed minus 8x squared plus 16x. They have a GCF. They all have an x in common. So I'm going to write an x out front first. So this would be x squared minus 8x plus 16 equals 0. Okay, factors of 16 that add up to -8. So 1 and 16, 2 and 8, 4 and 4. If you look at your chart, they would both have to be negative. Looking like that one. So we have x and x minus 4. Since I have the minus 4 twice, I'm just going to write it as squared. So this would tell me that x equals 0 and x equals 4. Okay. 2x to the 6 minus 10x to the 4th minus 48x squared. I can divide all of these by 2x squared, which would leave me with x to the 4th minus 5x squared minus 24. Okay, and then I'm going to do the same thing. I'm going to look at the factors of -24. So 1 and 24, 2 and 12, 3 and 8, and then 4 and 6. And if I look at my chart, it tells me the bigger number should be negative. These two, the +3 and the -8, add up to that -5 for me. So I'm going to write this as 2x squared. Since this is x to the 4th, this will be x squared plus 3 and x squared minus 8. Okay, looking for my zeros. This one doesn't have any addition or subtraction, so it would just be x equals 0. This would be x squared equals -3. And this one would be x squared equals 8. Anything that has a squared, I do have to work further. So this would be x equals positive and negative square root of -3, which 3 is not a perfect square and it doesn't break down, but I will write it as I square roots of 3. Okay, so x equals positive and negative square root of 8. 8 is not a perfect square, but it does have a 4 in it. So I'm going to take the square root of 4, which would give me positive and -2 square roots of 2. Okay. On number 13, this one's not set equal to 0, so we do need to do that first. So if I subtract that 8 from both sides, I get 3x to the 4th plus 2x squared minus 8 equals 0. Now this does not have a GCF, but it does have a number out front. So remember, when it doesn't have a GCF, but it does have a number out front, we do have to multiply these right here. So 3 times negative 8 would be negative 24. And then I'm going to list out those factors the same way that I did over there. So 1, 24, 2 and 12, 3 and 8, 4 and 6. If I look at my chart from before, it tells me the smaller number is negative. That means I'm looking at these two. Okay. One of the things you do need to remember is that we multiplied here. And if you want to write that, you can. But because we multiplied, we're going to have to divide these. So I'm going to divide both of these by 3 and see if they simplify. Okay, that one doesn't simplify, but the second one does. It simplifies as 2. So this is x squared 3. You don't have to write them as factors. I'm going to erase this for just a second. Okay, so when we go to write these, you can write them as factors if you want. If I were to write this as factors, it would be 3x squared minus 4 and x squared plus 2. Or you can go straight to their zeros. Their zeros are the opposites. So this would be x squared is equal to positive 4/3 and x squared is equal to negative 2. I do have to square root these. Ah, Elliot has the hiccups if you can hear him. And then x equals positive and negative square root of negative 2. And now, again, this negative 2 has to be written with an I. And there is a different way to rewrite this square root of 4/3, but we can talk about that when I get back. I'm not too worried about it right this second. Okay. So 14, 5x cubed minus 3x squared plus 32x. I do need to put everything on the same side, so I'm going to subtract that, and I'm going to subtract the 18. So this would give me 5x cubed minus 3x squared. If I subtract that 2, I'm subtracting it from the 32, so that would be plus 30x and then minus 18. Since this has 4 terms, I want to do what's called grouping, which means I want to cut this one in half, and I want to look at each side individually. Uh-oh, we're getting angry. This has an x squared in common, so this would be x squared, 5x minus 3. This one has a 6 in common, so this would be positive 6, and that would be 5x minus 3. So then my factors are x squared plus 6 and 5x minus 3. Okay, the x squared plus 6 comes from the 2 that are out front from our GCFs. The 5x minus 3 is the one that's repeated right here. Okay, so this tells me that x squared is equal to negative 6. So x is equal to the positive and negative square root of negative 6. So x equals positive and negative I square root of 6. Okay, over here, this tells me that 5x is equal to 3. Dividing both sides by 5, I get x is equal to 3/5. Okay, almost done. Only 2 left. Give me just a second, little man. Okay, I'm going to cut this one in half. This one has an x squared in common, so this would be x plus 2. This one has a 5 in common, and then it would also be x plus 2. So this would give me that x squared plus 5. and then that x plus 2. This gives me x squared is equal to negative 5. So x is equal to positive and negative square roots of negative 5. Since there's a negative in there, I do need to pull that I out. And then this side is x equals negative 2. Nothing else to do there. All right, last one. Just did orange. Okay, same thing, cutting it in half. This one has an x squared still, which leaves me with 2x minus 3. And this one, since there's a negative on that 32, it'll be minus, and then it looks like they have a 16 in common, which would give me 2x minus 3. That gives me x squared minus 16, 2x minus 3. You can factor this one further if you want, or you can just continue to do the way we have been doing it. This would be x squared is equal to 16. So that means x is equal to the positive and negative square root of 16, which, lucky for us, 16 is a perfect square. It's just 4. And then this one would be 2x equals 3. Dividing both sides by 2, I get x equals 3 over 2. And that's that. I'm going to go tend to this upset baby, and I hope that answers any questions y'all have. And then hopefully y'all have some time in class either today or tomorrow to finish up that assignment. Bye, guys.